Good morning to everyone. My name is S.M. Javid. I am studying in BTech in SRIT. SRIT. Today our topic is crystalline ceramics and their structures. Subject name is material science and metallurgy. Introduction to crystalline ceramics and their structure. Introduction crystalline ceramics. Crystalline ceramics are inorganic non-metallic material is known as their high strength and thermal stability. They are characterized by well-defined and repeating atomic arrangements. Common application include structural components, electronics, and dental materials. These are daily use our used the ceramics. One of the example is daily use tiles and wood. This like this. Zinc crystalline glass composition: 25% of silica, 25% zinc oxide from crystals, 50% fluctuate lower melting materials. Definition of crystalline ceramics. Crystalline ceramics are material that exhibits crystalline structure without atomic arrangements. They differ from the atmospheric ceramics which lack long range order. The crystalline nature contributes to their unique mechanical and thermal properties. Examples of structures: rock salt structure and also fluoride structure, uh, spinel structure. Types of crystalline ceramics. Major types include oxide, nitrates, carbides, and silicates. Each type of exhibits distinct properties and application based on the composition. Understanding these types of crucial selecting material of specific applications. Crystallines of ceramics. As with a plastic, the atmosphere ceramics tends to transparent. The structural ceramics tends to be crystalline and show greater strength, well stability, and high temperature. And also they structure anion packing with the examples. Crystalline structure in ceramics. The arrangement of in a crystalline ceramics from the specific crystals. Common structures include the faced cubic body, centered cubic, and hexagonal closed packed structures. The crystal structure influences the properties such as the density, hardness, and thermal expansion. And also their structures will be simple cubic and body centered cubic. Common crystal systems. The seven crystal systems include cubic, hexagonal, orthogonic, hexagonal, trigonal, monoclinic, and triclinic. Each system has a unique symmetry and dimensions that affect material behaviors. Understanding these systems help to predict how material will be react to under the stress of heat. Seven crystallization systems and also cubic, tetragonal, hexagonal, monoclinic, and triclinic. These are dimensions and their structures. Atomic bonding in crystalline ceramics. Crystalline ceramics is primarily exhibits ionic and covalent bondings. Ionic bonding provides strength and high melting points, while covalent bonds enhance the hardness. These are daily used the crystalline ceramics like wood and so many properties used. The type of bonding effect on material overall properties include electrical conductivity. These are used also the electrical. The ionic bonding electrons transfer from the Na and Cl, the share electronics, and also covalent bonding atomic share electrons. Metallic bondings, free electrons and ionic surrounded by a free electrons. Properties of crystalline ceramics. Crystalline ceramics are known for their high hardness and compressive strength. These are given as a compressive strength. They exhibit low thermal and electrical conductivity, making them suitable for insulation. Their brittleness is a drawback that limit their application in some contexts. Silicon. One of the example is silicon properties and use. Property: durability and low cost and material. Use of silicon: grinding, honing, water jet conducting. High application and temperature of bearing the furnace pots. high thermal conductivity and high maximum current density. Semiconductors materials in electrons. High voltage depend on resistance, lighting reactors. Manufacturing process of ceramics. Common manufacturing techniques include sintering, hot pressing, and CGL processing. These methods allow from the precise control over the microstructure and properties of their ceramics. The choice of manufacturing process influences the final performance of the ceramics. Then their structures, powder laying, roller. These are the procedure of the manufacturing of ceramics. Powder layering, roller, powder work area, and also laser centering, laser source workpieces, laser scan mirrors. Last the process is powder layering. Powder matrix, workpiece, roller. These are the preparation of ceramics. Role of microstructure. The microstructure of crystalline ceramic, they determine their mechanical and thermal properties. Grain size, porosity, and phase distribution can be tailored during the processing. Fine turning the microstructure can be enhanced strength of durability. Phase diagrams of ceramics. Phase diagrams are essentially for understanding stability of different phases of ceramics. They illustrate the relationship between temperature, pressure, and composition. Analysis of phase diagram helps to predict the behavior of material during the process. Phase diagram, pressure and temperature. Solid triple point submission, these are lower the deposition. Melting freezing is the outermost point, it is liquid present on liquid. Vaporization gives rise to condensation, it gives to critical point, bottom of the presence is gas. Application of electronics. Ceramics are usually mainly our house requirements. Crystalline ceramics are widely used in electronic components like capacitor and insulator. These are mainly used for our home electronics and electronic devices. The insulating properties are critical, the preventing electrical interfacing. Advance the technology continue to expand their role of electronics. Standard ceramics captions are surface mount ceramics, unlike multiplayer or mono block. High voltage disappeared, a trimmer of ceramics trimmers. Types of ceramics are capacitors. Applications of constructions. Applications of constructions. Its construction crystalline ceramics is utilized from the lies bricks structural elements. Their durability is authentic qualities make them popular choice of building materials. These are withstand harsh environmental conditions, ensuring the longevity. These are applications for drainage pipes and expanded clays, wall tiles, floor tiles, and also roof tiles, bricks, paving, and some of the examples. Applications of medicine also used the ceramics, like the crystalline ceramics play an important role of biomedical applications such as dental implements. Their biocompatibility and mechanical properties make them suitable for photostatic. Ongoing research continue to enhance their performance of medical devices, like applications are medical applications. The dental restrictions like root canal use the type of metal used the ceramics. Dental implements, artificial joints, synthetic bonds, and substitute. Their structures are also given as a clinical complications. Mechanism: find the grain phase transformation, micro crack the deflection between crack and bring pull out. Environmental consideration. This production of crystalline ceramics can have an environmental impact, including an energy conservation, recycling, and substitutional practice, and increasing important these industries. These are widely used for the industries because these are environmentally not polluted and also given as a high strength and mechanical properties. Innovations are being developed to minimize waste and improve the sustainability. These are logo like the ceramics of these are not polluted and it is eco-friendly. Future trends of crystalline ceramics. Advancement of nanotechnology are expected to enhance the properties of crystalline ceramics. Research into multifunctional ceramics will be expand their application across various fields. The interaction of smart material is a promising the frontliner of future development. These are used in the house decorative items. Zinc crystalline glass composition 25% of silica of the is present on a main body, 25% of zinc oxide from the crystals, 50% of structure, lower material and melting points of materials. Challenges of crystalline ceramics. One major challenge their brittleness which limits their use in a certain applications. Developing tougher ceramics remains a significant area of research. Understanding the failure mechanism crucial improving their reliability. Types of crystalline solids. Type of solids from the unit particles forces between particles properties and their examples. Com- Comparison with other materials. Unlike metal, crystalline ceramics are superior in a hardness but are more brittle. Compared to polymer, they offer better thermal stability but can be behavior. Each material glass has its strength and weakness making them suitable for different applications. Classification of materials. These are divided into four: metals, polymers, ceramics, composites. Testing and characterizations. Characterization techniques include the X-ray diffraction, scanning, electrons, microscope, and mechanical testing. These methods are provide insight into the structure and the properties of crystalline ceramics. Regular testing ensures the material meet required standard for a safety and performance. These are used for a high mechanical properties like medical also use X-ray scanning methods or characterizations of advanced material workshops. Summary of the key points. Crystalline ceramics are vital material with unique property influenced by their structures. Their applications span multiple industries including electronics, constructions and medicines. Ongoing research is essential for advising their performance and expanding their uses. General properties of ceramics: brittleness, flexural strength, creep and hardness, plastic deformation, viscous flow, porosity, and chemical durability. Conclusion of questions. Understanding the crystalline ceramics and their structure is crucial for material science. Their unique property make as indispensable and modern technology and constructions. Questions. Let the discuss any aspect their interest you are further. Feel free to adjust my details or my visual enhance the presentation. General properties of ceramics: brittleness, structural strength, creep. Thank you.